vacation break. It's Thursday, April 24th. This is take 2. I've already made this video. Unfortunately, I ran out of space on my computer. So I've spent the last 30 minutes making the first video, then the next preceding hour cleaning up my computer to provide some space to do this video. So let's get to it. This is the detailed answer key for the radical assessment that we took the day before, a couple of days before we went off for Easter break. So first of all, when simplifying radicals, there are 3 different types of radicals. One set are perfect squares. Perfect squares are square root of 36, square root of 16, square root of 25, etc. Those are all perfect squares. Everybody should know perfect squares between the square root of 1 to the square root of 144. Those are the ones that you should probably know. You should probably know it all the way up to square root of 200, square root of 400, which is 20. That's a perfect square. Square root of 400 is 20. And so those are the perfect squares. Most students in high school will know those 1 through 400, all the perfect squares. But we're in 8th grade, so we're just going to have you, I expect you to know it up to 144. So when we see the square root of 36, we should know that it's a perfect square and it equals 6. 200 is not one of those perfect squares. And so we have perfect squares. We have non-perfect squares that can be simplified. So ones that can be simplified are, square root of 20 is not a perfect square, but it can be simplified because it can be broken into the square root of 4 times the square root of 5. And the square root of 4 is a perfect square. And that turns into 2. So the square root of 20 can be simplified. And then the other is non-perfect squares that can't be simplified, like the square root of 13. That can't be simplified, so that is its final answer. So perfect squares, non-perfect squares that can be simplified, and then non-perfect squares that can't be simplified. So the square root of 200, so I'm going to break it up, and when I choose what numbers to break it up to, first of all, its product still needs to equal 200, but I chose 100 times 2 because 100 is a perfect square. So I can simplify that to 10 rad 2 because the square root of 100 equals 10. So there is my objective. Square root of 144, I notice that is a perfect square, and that equals 12. And then negative 4 rad 72. So what's happening to that negative 4 is multiplying rad 72. And now I'm going to break rad 72 into something that I know. I know that 9 times 8 equals 72. And I chose 9 because it's a perfect square. And so we get this. And now these are outside, so I can multiply those. And I get negative 12 rad 8. And many students stopped here, and that was unfortunately a mistake. We still can simplify rad 8. So when we're simplifying these radicals, we still have to make sure that we simplify it completely. So I chose 4 and 2 because 4 times 2 equals 8, and 4 is a perfect square. So I get negative 12 times 2 times rad 2, or negative 24 rad 2 is its simplified answer. All right, now we're going to go to adding and subtracting radicals. Adding and subtracting radicals, we can only add and subtract like terms. And like terms, when dealing with radicals, they have the same radical. So negative 3 rad 6 plus 7 rad 6, if they are like terms, which they are, we are going to combine their coefficients. And so we are going to combine negative 3 and 7, which makes 4 rad 6. So a lot of students confused this and canceled out the rad 6s. We don't cancel them because we're not multiplying, we're just adding. When we add things, we add like items, we combine their coefficients. Now these are unlike terms, but we're going to see if we can simplify this. So rad 6 cannot be simplified, but rad 54, and I told everybody to do this. I told you that you want to know what's going to work out best for you is if you just take that radical that you're going to simplify and do it off to the side. We're going to make this rad 9 rad 6, which makes 3 rad 6, and that is simplified. So it is rad 6 plus 3 rad 6. And remember, there's an invisible 1 here, so these are like terms because we are adding and subtracting. We are not multiplying. So 1 plus 3 makes 4, and that makes 4 rad 6. Way too many students cancel these rad 6s. We are not multiplying these, we are adding them, so we only combine their coefficients. Again, I would advise you to simplify these. This was another place that students struggled because they got their work all mixed up and everything. Take this one, negative rad 12. I'm going to break that into negative rad 4 times 3, and that's going to be negative 2 rad 3. And I'm going to write that underneath it. And now I'm going to simplify 3 rad 27. And I'm going to make that rad 9 rad 3. Rad 9 is a perfect square. And I'm going to keep the outside stuff with the outside stuff and the inside stuff with the inside. So this is plus 9 rad 3. Now, these are like terms. They have the same radical, so I'm going to combine their coefficients. Negative 2 and 9 makes 7 rad 3. This is lagging a bit, so I hope it's still not breaking. Let's see if I can get through. Number 8, you're going to have 2 rad 54. And we're going to break that up, and we're going to break rad 54 into rad 9, rad 6. Rad 9 is a perfect square. And now the 2 and the 3 are outside, so we can multiply those. And 2 rad 54 will simplify to 6 rad 6. And now we take 2 rad 24, and we're going to simplify that. So rad 24, I'm going to break into rad 4, rad 6. And rad 4 is a perfect square. And the 2's are outside multiplying each other. So that simplifies to 4 rad 6. So 2 rad 24 becomes 4 rad 6. And now we have like radicals, so we're going to combine their coefficients. And 6 plus 4 is 10 rad 6. So again, I'm trying to show you that it makes it a whole lot easier to simplify each of the radicals outside and then simplify it, and then you tend to see the like terms and what you're combining when we're adding and subtracting. So really important. I would advise, again, that you do it in that manner. Multiplying now we're going to break things up still, but notice that we are multiplying. So when we multiply like radicals, it cancels the radical because rad 5 times rad 5, we can look at it in 2 ways. We can see this as rad 25, which is a perfect square, or we can look at rad 5 times rad 5 as rad 5 squared, and that square will cancel with the square root, also leaving you with 5. So we like pairing, we like matching up because it will cancel the radical. And then rad 14 can't be simplified any further, so it becomes 5 rad 14. So remember, when simplifying, we're looking to match or look for perfect squares. Neither of these are perfect squares, so I'm going to try to find a perfect square inside it, like 9. And 14 doesn't have a perfect square, but I'm going to look to match that rad 2. So we have a perfect square here, which produces 3, and then we have a match here, which produces 2. And then you have your rad 7. The 3 and the 2 are outside. 3 times 2 is 6, rad 7. Still multiplying. A lot of students saw this negative and thought it was addition or subtraction, but there's a multiplication sign right there. So the outsides are 5 times negative 2, and then we have a match. We're multiplying, and we can combine these because everything is multiplying. So rad 6 times rad 6 is 6. 5 times negative 2 is negative 10, times 6 is negative 60. And now we're dividing, so we still are looking to match. We're going to make this rad 10, rad 4, and 30 to rad 10, rad 3. But this time, when we match, they're dividing, and anything over itself is going to create a 1. So these cancel each other. And we do have a perfect square here, so we're still simplifying. We have rad 4 over rad 3, and rad 4 is a perfect square. So we get 2 rad 3. Now we have to remember no radicals in the denominator in your answer. So we have to get rid of this radical 3 in the denominator. So I'm going to multiply it by something. Well, what's going to get rid of a rad 3? Well, remember our objective is to match. So if we match, we get 3. Rad 3 times rad 3 is going to give us 3. Now, we want this to be an equivalent value, so we can't just multiply it by rad 3. We have to multiply it by rad 3 over rad 3, which is a value of 1, and we would produce an equivalent fraction. So our answer is 2 rad 3 over 3. These 3's cannot cancel. One is in a radical, one is outside of a radical. We don't have a rad in the denom, and nothing else can be simplified. Number 13. So I'm going to break rad 12 into rad 4, rad 3, because I want to cancel these radicals. These cancel completely because they make 1. That leaves me with 1 over rad 3. That radical 3 is in the denominator. It needs to stay in the denominator after canceling these. And then we know we can't have a radical in the denominator, so I'm going to, well, I forgot to tell you what this is called. This is called rationalizing. We create a rational fraction. I'm getting sick, just as vacation is finishing. Rad 3 times rad 3 is 3. 1 times rad 3 is rad 3, and that is an acceptable answer. Last one. 5, okay, rad 8, I'm going to break into rad 4 and rad 2. Rad 20, I'm going to break into rad 4, rad 5. These rad 4's will cancel. And I'm left with 5 rad 2 over 2 rad 5. These do not cancel. Nothing here cancels. Okay, this is inside, outside, outside. They don't cancel. The 5 and the 2's, and the 2 and the 5 don't cancel. So I can't leave it like this. I have to rationalize it. I got to get rid of that rad 5. So I'm going to multiply it by rad 5 in the denominator. That leaves me with 2 times 5. These 2 make the 5. And in the numerator, I get 5 rad 10. I'm going to multiply like radicals. Now, I could make this 5 rad 10 over 10, but I see that I can cancel these. These both are outside, so I can cancel them. I know the cancel before simplifying, and that would be my final answer. Okay, so hopefully this helped you for your review. We definitely need to come up and see these problems prior. I gave you plenty of problems before the assessment for you to find these issues, but good luck. Come and see me. Reassessment on Wednesday.